Hello friends, so in this part I will walk you through the different data types and a structure. So data type and a structure are basic of any programming because it set the path of variable, how it should be interpreted during the processing, and it is very important for the precision and accuracy to get a good data. So let's start on this part. So let me go to CoDeSys. So let me start here with the basic data types, how and which are supported by the CoDeSys by default. So let me go to the PLC program. So I will try to define here one variable, and then we will set it up the data type for that particular variable, and we'll go one by one. So let me create a variable. So when we are writing in the text view, so either by input assistant or by control plus space, we can go to get the different data types. So you will see the different standard data types which are supported by the CodeSys. So all these are the data types which is getting supported, and we can select any of these here, and it will be then applied for that particular variable. If you want to go for any structured type, which we will see like any array or any function block or any kind of thing, so those things will be there in the structured types. So let me go to the help file also. So CodeSys provide a very good help file from where we can also learn and refer it. So the different data type which are supported and how much memory it consume, these are the very important thing when we are writing the program. So like data type will integer data type, so we have lot of defined integer like byte, word, d word, l word, signed int, unsigned int. So a lot of they are there, and what memory exactly they consume. One thing which we should be very cautious when we are defining the data type, we should be providing the actual data type which is needed for the particular data, so that during the conversion or during the when we are uh, reading any value, it should not get the loss. It should not be there, because when we convert from large to small, the data get we lose some of the data. So that should we should take care when we are writing the program. So data type, real, long real, how exactly the memory they consume, what is the range of this data type. uh, so string. So yeah, all those data types are pretty defined in the help file also, which I will be putting that in the link also. And we can get this help file also from the ID itself by going to the help menu in the menu bar. So time data types or date data types, lot of options are there by default provided by the CodeSys. So mostly all the PLC provide most of these data types. So this W string is uh, uh, extra data type, which is something for the large handling large data of the string part. So it supports 2 bytes per character. Okay, so this is the extra uh, data type which I have found. So, and yeah, this bit anyhow, so which is, but this particular structure is only supported I think in the function blocks, inside the function blocks. So this is pointer data type, means which it will be something like it will point to a particular uh, data type only when we are creating a variable or the function block instances. So it helps in that. Then array, the different array size, array data type we have, so we can create the array of any of the data types. So this is a kind of a structure which we can create uh, in the CoDeSys. And this any type is something like when we define any variable as any, whatever we pass, so it is something it will take it from there. So whatever we pass inside the function blocks or in the methods, then the data type which is getting referenced will be the data type of that particular variable. So I will walk through the different data types one by one. So let me create a structure itself. So inside the structure, uh, we will define different data types, and we will also see. So this is the user defined structure, so DUT, and where we have the structure, enumeration, union. So let me first define one structure. So when we define a structure, inside a structure we can define all the different kind of data type at one place. So like uh, if I have a combination of data types, I can define it here, and then I can utilize this particular structure in the program itself. So structures are very helpful when we have the combination of different data types, and we want to make a particular uh, uh, basically into a particular format. Then it helps a lot. So here I have defined different data types, and then let me go into the program, and uh, we will call it there. So I'll define one variable here whose data type will be the string dot underscore dut. So let me copy. Yeah. So as I defined it here, now I can, through this particular variable, I will be able to access all the different variables inside this structure. And so see here it is in1. I can directly utilize in the program. So as in1 is a real, so in order to assign some value, I need to define, or I can utilize this just to test here how exactly it works, whether the data size of the data type is the same what was defined. So all those things we will be checking it here. So let me variable I have mapped. Now let me check the size. So size of is a function basically through which where we can define that particular function and define the variable. It will give us what is exactly the size of this particular variable. So whether it's a 4 bytes or whether it's a 2 bytes or 1 byte. So it will give it that in the byte format. So what I was checking is whether I can go directly to definition or not, but I cannot go directly from here. So okay, anyhow. So let me define one more variable where I should be able to get the size. Okay, so with this particular things, it will provide me the size of this particular n variable. So in1 is real. So what will be the size? So it should be 32 bits, correct? So 4 bytes it will be. So in the courses, we have two options to do the validation of the logic. One is directly with the simulation enabled. So there is a feature called simulation, and another is through the PC based PLCs, which is there. So let me enable the simulation module here first, and we can go online. So it will put in the simulation mode, and in the bottom you will be able to see that whether it is running the simulation or not. So run will be green, but the simulation will be red, so it shows that it is in the simulation. So if you see here, right now the in1 was real, and the size of in1 is 4. 4 means it is giving that in the bytes basically. So let me make it as a array. So array of certain number. So for example 1 to 10 of real. Now if we see the byte, the size will change. uh, I need to, okay, I need to give in1 as now it has been changed to array. So in the first line I have to give the array number, which one it should be referring. Now let me compile and log in. Yeah. Now if you see, so array sizes of 10. So 10 into 4, it's 40. So this is how exactly the size will differ when we define number of variables or even the array structure. So based on that, the size will differ, correct? Okay, so let me, we can also check in the PLC shell what is the memory getting consumed when we write this particular data types or data structures. uh, okay. Okay, so here it is not giving because we are in the simulation mode. So what we can do is we can go and start working with the PC based PLC, which is, so let me start that. So this particular PC based PLC will run only for the 2 hours in the demo mode. So we can go online from here. So it detected, and I will download the program. So it is an online change. Now whatever the value we change, it will, here also it will reflect. So we can use control F7 to write the value. Okay, so let me create another variable. So we can also define this array with by defining a variable as a constant and defining uh, a number for that, and then we can utilize this particular variable in the array. So instead of defining that directly there, we can also define it like this. So this is just another way of representation which I wanted to put it here. And now let me go online. So online download we will do. So it remains the same. Means only the way of representation change, but the data type and everything remains same for that particular variable. So it doesn't have any impact. And now if I go to the PLC shell, and we have different commands to check the memory. So one is the MEM. MEM is, we need to also pass with MEM the particular memory address, and then the PLC load. So you can see that right now it is running at the 3% of the load. So different cores, and all the cores at what percentage memory it is consuming. So in this way we can be able to see the memory consumption when we start writing the code and when it get bigger and bigger. So let me just change this particular value to a different number, whether it has any impact or not. So let me download it in. So right now it is 4 byte, and if I give the PLC load, it is still the 3%. So basically this PLC load doesn't vary much with the small change in the code. So that is what I wanted to check it here. So when we are writing the particular code, so these codes are when they are getting generated and loaded into the PLC, they are of the very small size, correct? So it now I have increased the size to other size to 1000, and now let's see. So 4000 bytes, whether it has any impact or not. So if you see, it's still 3%, and now yeah, so it has gone to a little change, is 4% of the memory consumption. So when we are defining something like that, a little variation we can see. So based on the code what we are writing, based on the data types or the data structure which we are creating in the code, it will have the impact on the memory part of the PLC also. Okay, so that was just for the checking, and how we can do the mapping between the PLC memory and the data types when we are writing any particular code. So it will help us for the better programming and better memory management, because the microprocessor, they mostly say that whenever you are writing, and the data type you should utilize which is very relevant for your the data which you are trying to show. So that is why we should be sticking to a particular data type. So let me define another data type. So this particular data type which I'm going to define is the pointer. So I will talk here about the pointer. So what is a pointer? Pointer is basically a variable that stores the memory address of another variable as its value. Okay, so and it points to a particular data type only. So when we are defining, let me show you here how exactly it works. So I defined a pointer and variable to pointing to the int, and I'm trying to when cast or assign the value of the real, we are getting the error correct. So because it need the data uh, which will be the integer only, it cannot take any other data type. There are ways to convert the data type and assign it to those pointers, but that will be something we will see later. So, so I defined again a variable which is int 3 and trying to assign it. Okay, so here we will not get any error correct because the pointer is pointing to int data type, and I defined another variable which is also of int. So both are now matching, so it will work. Another way which I was talking is the ADR part. So ADR is an operator which is for the which works for the address. Basically ADR is for the address. So what it do, it yields the 32-bit address or 62-bit address of the argument. Whatever the argument we are passing from there, it will yield into 32-bit address or 64-bit address, and then provide the value. So let me show you the help of this particular ADR. So here it is. Yeah, so if you see here what it do, it yields the 32-bit address or 64-bit address of its argument. So whatever we are passing, so mostly it will be like d word, all word, and points to, so then it will be working in that condition. So you see here we have an pointer to int. So how we can define, so the different address, different data type, and that's what it is showing here, that it works for 32 bits, 64 bits all. So let me go to the program. So if I change it to real is a 32 bit correct. So let me do now, and n3 is int. So if I do n3 to real, it says no, it cannot be assigned, int cannot be assigned to a pointer to real, but it is just a warning. So let me download the program and we'll see how exactly it works and what value we get. Okay, so now if you see for the n3 the value is 5, but what it is telling me is invalid pointer, difference of invalid pointer. Okay, but in the address, if you see, it is having some value, correct? Now if we change it to int, from int to int, we'll make it another one, so we can check at the same time different values, how exactly it works. So info will point to in3. So now if you see, both are getting value, but let's, when we go and check in the details, so I'll change it with ADR, because ADR says that it else in 32-bit and 64-bit, correct? So let's, now let's check it out. Yeah, the parameter changed. And there's one more point, that when we are working with the pointer and ADR, then when we are passing the values, or when we are changing the value, it should update uh, in every cycle. Means it should not be something like it should not get updated, so that should happen. So now here, when we do the ADR, then it both are the same at memory address, but if you see, the values are different. One is 5, another is 1.8 something, which we are getting. So in the real format, it is giving us a different value, not exactly the 5, correct? But we should have got 5. So let me create another variable. We will do some more checks, and I'll try to show you different use cases, how exactly it works. So in 5 I'm mapping to n2, and in 6 I'm mapping to n4. So now build. So cannot convert into pointer to int to type int, and pointer to type real to real. Okay, so this we cannot do like this, correct? Because pointer cannot be pointed to another variable, but it will be the address of some, as we told in the beginning. So we need to put this address or ADR operator, and then it will solve the problem. No. Okay, so let's change the way it should be getting written. So there's another feature, when we are putting this particular pointer variable and pointing it to some another variable, there's another way to do it. Okay, so let's go to the help file, and we have, if you see we have another operator or another symbol to do this particular thing. So by putting that, yeah, this one, it will not give us the error. No. So there are different ways of accessing. So ADR is to access from pointer to the variable, and uh, the symbol which we are using is for pointer to the variable. And so now let me change and see if this works when we have two different uh, data type. So it will give us the compiler. I downloaded it, but let me do. So it has no impact. So it also doesn't work when we have a data type of two different types. So even if I try to put ADR or anything like that, it will not work. So these things we should be cautious when we are working with the pointer, basically. So the correct way is that the pointer, when we are referencing to the pointer from any for the data type which is getting pointed, we should use ADR. And when we are doing from pointer of a particular data type to the variable of that particular data type, then we should use the symbol of uh, up arrow, basically. Okay, so let's go to another type of data type, which is, or the structure, which is something like enumeration. So we will define enumeration. So enumeration is basically where a data type where we define a collection of data using comma separated in the courses. So uh, enumeration, like we can do something called even the dictionary, that we have some key, we have some values, or we can have also a definition of only of the values, like strings values. So anything which has the collections, okay, so that we can define it in the enum type. So that let me define, like I'm taking example for the pump, like pump or any electromotor compressor or anything like that, which has a start, then it accelerate, then ramp. So that part I'm trying to define in control, and then a stop. So for every different uh, steps uh, which is having a string, and it has a int value as a key. So key and value. Okay, so this is a collection, and it is the enumeration, basically. So when we define or use that particular data type in any of the program, so like a machine state, and the data type is enum dot. Okay, so let me show you how exactly these things work. So let me define another variable. So here I'm trying to define that, okay, a state machine, and it has machine state which is enum data type. Let me save and download this particular program. So when we go online, okay, and to see different types also. So enum dot, again I'm defining one more, and if you see here, I'm defining that as a stop, machine state as a stop. Okay, whether it will take, it will not take, because stop is a collection inside the DOT. So this way we cannot define. So how exactly that will work? We'll just let me utilize this variable in the program. So I will compile, and in the compilation, let's see, it gives us error, correct? So because the data type is enum underscore dot, not enum underscore dot dot stop. Stop is a collection inside that, so we cannot define any data, any variable with that particular data type. This is not a accepted format, but I can utilize that in the program directly, that particular data type. Instead of defining there, I can utilize that in the program. So when we download, we see that what we're getting is the integer value for that particular collection. Okay, so we had like and so let me change it, the prepared value. So here you see, because our collection was like start, and then for that there was an integer value. Okay, so when I change it to acceleration, the number will change. So what I'm trying to do it here, that from the HMI, when we are connecting with the HMI or any where their user will not understand 1 2 3 4, correct, but we need it here, the integer value. So in the drop down it will be showing as the string, and from that string the key will be sent into the PLC code, which we can utilize basically in the code, and process our logic. So what we can do here is, we cannot define like this, but we can define it as a enum underscore dot and initialize with that particular value. So that is an accepted format when you are working with the enum variable, and then we can put the machine state one also here instead of enum dot. So these, either of the way, means what we want. Okay, so is okay, so if we want to keep as a constant, then we can directly define. If we want to keep it as a dynamic, that we should be able to change it, then we can define it like this, and it will work. So we are able to change from different values. Okay, so let me define another data type as union. So union is a data type which also has a collection of different data type, but it utilizes the same memory space. Okay, so the difference between a structure and union is that a structure provides each space to each variable, but union actually work in the same memory space for all the variables. So I'll show you how exactly it works. So because if any changes happen on one variable, it will have impact on all the variables which are defined under the union, and it is useful when we want to have the conversion in different data types. So let me show you how exactly it works. So we have the I have defined one variable. So let's first see the size. So when I was talking about the memory, So how exactly it do? Okay, so let me download. Okay, so you see here the union data type which we have defined, it has three different data types inside that, but still the size of that whole variable is 4 bytes. Even we have three, if I go here, three different data types of 32 each, 32 bits. So basically it should be 4 4 4 12, but what we are getting there as 4 only, because it utilizes same memory space. Okay, and when I change one variable, you see it do the has impact on all. Okay, so the first one is 1 and last one is 1, because they are of d word and d int, so they are of almost integers category, so the values are same, but for real it is converting. Okay, so if you see, I have utilized d word to real, so when I give 1, what the real value it will convert is 1.4. So this is what exactly it is getting done there. So that's what I'm trying to do on the bottom. So now in the structure we have also multiple. So let me define another structure of the same data which are there in the union. So it will show us exact difference what it has, the difference between the structure and the union data type. So I'll copy. So it is pretty easy when we want to change uh, any data type or anything. So we just have to rename from union to structure and make that happen. So it will convert to a structured data type. Okay, so I'll define a variable in the PLC program and define it with the structure type. And let me define those same three variables for structure also. So when we work in the structure test, it is easy to do the copy paste here. So, but it is uh, individual choice, means in which programming language they are comfortable. So those who understand logic based on the relay part, they will be happy to work on the ladder. Those who understand more of K-map and the digital circuits, they will be happy to work on the FBD. And those who want to write the basic, or those who are from the software programming part, they will be able to write in the structure text easily. So yeah, I have put all the details here. So now let's see the difference, how exactly it brings. So first thing is same number of variables and the sizes are different, 4 and 12. And when I change for a particular variable, it only changes for that particular variable, because each variable defined inside a structure has a different memory, so it doesn't impact others. But in the union, if I change, it will impact others. So in order to change the data in a structure, it should be changed in all the variables, but in the union, it doesn't need. The sizes, you see, the 4 and the 12. So it consumes 12 bytes, that consume only 4 bytes. So basically, when we have to define a program where we need to provide the data in different formats, there we can utilize the union, it will be easy. Okay, so these are the differences, basic differences. So let me go to string data type. So let me define here a string data type. So strings means there are two different type of string. One is the basic string and another is uh, W string, and then also we have in the string we can define for a particular length. So a string, in that one we have to define uh, the character or how much we want. Okay, so these are two different uh, ways. So let me go to the show you the help. So data type string, how we can define it is in this particular format. So you can go through this document also. So let me put a description and how exactly it differentiate when we have defined the string data type. So let me put one tag name and description, so and we'll download it. So string character defined as 55 there. Okay, I'll just reduce this to 20, so that we will see exactly what happens when we have a predefined number. Let me do one more. And here I will change the length to 63. Copy it, paste it, change the variable name, and let's download it. So now if you see, we have defined the description, correct? So first we had 20 characters, so it has truncated the values after 20 characters. Now for another one it was 63, so it is giving us the whole, because that I counted. So it was almost 63, so that is why I put the length as 63 there. So that is how exactly this differentiate. So one is the string, which will anyhow give you the full. One is the width, the length of the character till what we want. So that is how it is. So it is not compatible. Okay, because we have hard coded it, correct? So it will give for all, because these are hard coded ones. So it is in the program, it will take it from the program itself. Otherwise we need to define another variable and then we can be able to do. but that's okay. So it is just about the concept, correct? So how exactly these strings work. So another one is W string, which caters more number of character, and the way of defining it is a little different. So it is in double inverted comma and double quotes, and that was, sorry, it we represent that in the double quotes, and the normal string we represent in the single quotes. So let me put another disk tag for W string, and define the text. Compile and so you see why it is giving, because still it is in single quotes, so we have to change it to double, and then it will not give us the error. Okay, so we can see, so this is the string data types. Okay, so let me walk you through date and time data types. So date and time, so we have different types of format for the date and time, and we can convert from one format to another. So these are the defined formats which are supported by the CoDeSys, and how it should be represented, so that is also given here. So let me go to the code and let me define. So what I'm trying to do is I'm trying to get the date and time in the UTC format, and then putting it into the exact date and time format, so into the different resolution. So date to date format. Okay, so LTOD, let me download. So once we download, we will see in the date and time coming in the UTC format, which is, if you see, when we separate date and time, it is giving the date of today and the time also, what is the current time in the UTC. If we take this particular millisecond UTC time and go to converter, this is 7:30, and let me put it here. So convert to date. Okay, so this is the we are getting is the local time, correct? Local time is of 1 o'clock, but UTC time is 7:30. So with there we get the time in the UTC format of the millisecond. Okay, So 734, and here also you see 734, and it is giving in a long time format. So there are different ways to again change the formats. Now this particular get date and time is getting used from the util library of the CoDeSys itself. So there we have this function block function from where we can get the date and time. There's another way also to do this the same thing. So let me show you that one. So that is systime RTC. So when you type it and put control space, you will get all the different functions and everything. So let me get a high resolution system. So it will give us again the UTC time in the system time format in the millisecond. So this particular function we can utilize to get the time in UTC format in millisecond. Okay, and then let me convert it to high resolution local time and date. So there were earlier also UTC to local, which is now obsolete by in the latest versions by the CodeSys. So for in spite of using the local to UTC, convert local to UTC, we will use systime RTC high resolution, not get. Sorry, let me change this. So RTC high, RTC convert high resolution to local. So this particular, what it will do, it will convert the UTC time when we pass to the local date and time, which is the system time date format. Okay, so let me download. You see both are giving us the UTC time in millisecond, but the conversion in period, it is giving us the year, uh, the hour, month, everything it will give. Okay, so year of the day, day of the week, so all those details will be shown here. So you see the time is, the date is 5th, so it matches with the system time and date exactly how it is. If we copy this one and again go to, okay, let me, so this is about the get. Let me also show you for the set how we can change. For example, if you want to synchronize or from different place and synchronize your system into that particular date and time, then how we can change that particular thing. So we have to use system time RTC high resolution set, and then we have to put that as a p timestamp. So whatever the value we will be putting, that will get reflected. So let me get the time in millisecond. So okay, so this is what we have. So when I put this particular, it will give me the date and time, correct? So now let's utilize the same UTC time to set a change. So let me change anything. Let me find another day. So still it is January 4. Okay, so January 3. So let me take this particular millisecond. and let's go to CoDeSys. So I will keep it in slash with this particular time, and let me define these variables. So we should always put these things on the condition, correct? Otherwise it will keep changing to same date, and maybe it can get hanged sometime. So okay, let me make it okay. Here it is still 0 because we did online download. So let me get that value again, copy it. Okay, so let me put it here, control F7, then double click, control. So as we do, and we see that the time got changed, date and time both got changed. Okay, so let me show you another way. So this is means you need to know the timestamp, the time in millisecond. So we can also do using directly using date format. So for that we need to use system RTC convert local to high resolution, for which we need to give a pdate. So pdate is the same thing in the pdate system time date format. So let me download the code. So what we need to do is we need to go to the pdate. So here right now we have a date of 5. Okay, so once we put again control F7 true, you see the time and date got changed. So that is how exactly we can even set the time and date for any controller. So now let me take you to add any data type. Okay, so I'm putting here the set data as any, and this is a function block. So okay, let me put it here. So you can see that the how exactly it is shown. So data type was int, set data type, so it is showing that as int when we are passing it internally, and the value which we will change, it will get changed. Okay, now I will change the set data from int to bool, and again we will download. Okay, so now if you see, the data type got changed to bool. Okay, and it will be the true and false. So for any, when we set a data type as any, we can, whatever the value, whatever the parameter we pass from the out to the function block, that will get reflected inside. So let me show you another one as real. So we can keep playing, but so whatever you want we can put, and it will work accordingly. So you see here the type got changed to real, and 12.23 I would, but it is there coming as a 20 because of the pointer to byte. Okay, this is coming because of the pointer to the byte, so it is showing in the byte format internally. So this we need to also keep check. So it works for integer, it works for boolean, but when we go to 32 bit data, then we need to be little careful. So that's all. Thank you. See you in the next video. Keep watching.